Okay. So in SQL, we were learning DQL statement. Okay. Yesterday, it was the first class for us. So any stuck point so far from anyone, whatever we have learned, I'm just quickly repeating. We have learned the aggregation function, sorting stuffs, as well as the filtering operations, slicing of the data set. Those things we have covered in the last working day. Along with that, we have created a new derived column with our hands-on part. So, any stuck point from anyone till now? Anyone is having any doubt? No one? Okay. Okay. Let me start today's session with subquery. So, what is subquery? Let me go through the particular database. Okay. So, whoever has joined as new, so this is the database we are working. It's MySQL databases. It's an open source free software. That's why we downloaded at our systems and we are doing the hands-on part in this database. In the database, in the left-hand panel, you can see all those database schemas are present over here. So we chose the schema for our working purpose and we have created the schema. Okay. So you can also try this kind of things. If you have any other databases at your side, at your system, you can also have a hands-on on that side. There will be no issue with the other databases as well. The syntaxes are 95% same across the databases. Few of the databases syntax are different, just like the inbuilt function. The inbuilt function, just like yesterday we learned concatenate. The particular function we used concat. Okay, so maybe there are separate databases installed in our system, maybe Oracle, MS SQL Server, any other databases. So the concatenation functionality should be same, but the syntax to represent concat, it can be a different. Some of the systems they are using this kind of thing. They are not using any function. They are just using this kind of thing. String one, double pipeline. This is for concatenation. String two. String one means a column one. Concatenation column two. Concatenation column three. So this kind of operator is also there. So based on the experience, I think we just need to clear the functionality first. We need to check the syntax as well. But for across the different databases, some of the syntaxes varies. Those things you need to learn. Maybe in your project you are having a different databases. Whatever we are learning over here, it's not there. But no need to worry about it. 95% syntax are same. The functionalities are totally same. Just you need to have the knowledge what is the changes over there. You need to quickly search it from web as well, that the concatenation representation in this database. It will be quickly help you. Okay. Similarly, the date data type I have mentioned earlier. So this thing I'll be repeating once more time when we'll be doing the exercises. Today I'm just starting our first topic, that is subquery. Okay. So let me just go through the table once. Actually, this particular table we have worked on the last working day. Select star from employee. Let's check what's the data in employee table. I'm going to execute this. Okay. So I'm just selecting data from this table and we can see the table is having 10 records with those column. There are employee ID, employee first name, employee last name, experience, salary, department, date of birth. And if anyone is quite interested to see the DDL, you can see the definition of the columns. Employee ID is integer, data type, employee first name varchar, this is varchar, experience is integer, integer, department is varchar, date of birth is date data type. Okay, let's go ahead with the subquery part. So what is the concept of subquery? Okay, maybe someone told me, maybe some managers told uh, um, to me that help me with the particular person who is having the highest salary in IT field, department IT. Okay, someone told me in this way. or help me with the highest salary, not in IT department, highest salary of the organization. Okay. So how I can get it? I can use a max function. That is fine. I can use the max function, but from the max function, I cannot get the return who is the owner of this highest salary. Okay. I can do in this way. Salary from, this is the aggregation function we learned the last day. Select max salary from employee. Okay. So I can get the maximum from here, but the name of the employee is not there. So I need to search with this particular value again into the employee table. How should be that? What should be the thing? Select star from employee where salary equal this. So this should be the output. Shweta Pandey. He's, I mean, all the details of her is present over here. So I'm performing two separate query to answer this question. You can quickly check from the databases as well. As of now, there are 10 records. You can quickly check which is the maximum one and you can answer them. But suppose there are thousands of records. It's not easy to check from the database and answer this question. So here is the concept of subquery can be achieved. So we are using two separate queries over here to get the result from subquery. Okay, we can do one thing. Instead of presenting this 2,50,000, I can copy this thing and paste this thing over here. I can put a bracket. Let's put in keyword over here just for safer side. Okay, so select star from employee where salary in, and this particular query will be giving the output of this filter. Okay, let's run the entire query. This is a single query. Okay, so what we are doing, we are taking input from this query. Whatever data set we are receiving as the output of this query, we are taking input, and the same input is fed over here as a filter condition. So this kind of operation we can do over here. The usage of this condition, this kind of query statement, it's called a subquery. Okay, query inside another query. This is subquery. This is very, very helpful to minimize our effort. Okay, so this kind of thing, obviously, you can, understand. We are getting output from one particular query and going to feed into the main query. Similarly, suppose this kind of thing. Just going to give another example. Suppose this is our select star from employee. Not this. Okay, so this is the output. On top of this, I'm taking this data set. On top of this, I'm doing a slicing part. Select employee ID, employee first name. From, I'm taking the data from here. I'm not mentioning any table name over here. Rather, it's taking the input from this data set. Whatever it's returned, it's taking it from here. Select employee ID, employee first name from this data set. Okay, I need to alias the entire data set with a name. Otherwise, it will throw an error. So, the similar kind of column aliases, whatever we have learned in last day, we can do table name aliases over here as well. So, select start from employee. I have alias the data set P. Now, I'm doing select employee ID, employee first name from this data set. I'm not mentioning any table after from clause, after from keyword. Okay, let's run it. Yes. So it's taking input from here and giving the output to this. It's also working as a subquery. So this kind of operations are called subquery operation. Okay.
I have a question. Yeah.
Yeah. Any
So
doubt? Yeah. Tell me.
what is P here?
P, I'm aliasing the data. I mean, this data set. Okay. Just like column aliases we learned on the last day. We can
Okay.
do anything, not P. I mean, we need to put a alias. This data set, you need to put a name.
Okay.
Okay. You can also put as EMP. I'm just putting in this one. You can put as, you can omit as, just like the same alias concept yesterday we learned that after putting, I mean, one column, we can rename the column names over here. We can put as keyword, then put a name that you want to represent the data set. And you cannot put as well. You can just put a simple space. Anything you can do. Over here, the same concept. Okay.
Okay. What if you don't put anything there?
No, it will be throwing an error.
Okay.
Let me run it. Every derived table must have its own alias. So it's a derived table. We need to put a alias over here. Okay.
Okay.
Suppose I'm just aliasing the entire data set. This data set has EMP. Okay. Now it's select employee ID, employee first name from EMP. This is the concept. Okay.
Okay. Yeah. Thank
Yeah. Okay. No issue. Any other doubt from anyone during learning the subquery part?
All good, sir.
Okay. Fine. So the next topic, it's very, very important. During your working phase, you can find this kind of thing. Create table from another table. So we have learned DDL at the first day of SQL. So in the DDL, what we are doing first time, we are creating table with the conventional, putting the column names there, data types. If there is any constraint, we can also try to impose the same thing over there. But suppose I need to copy a table from another table. I need to create a table in a shortcut way from employee table itself. So I do not have to put everything just like this employee ID integer another time. I can directly create a table from employee. Exactly whatever I required, whatever employee table is consisting, I can create a similar copy of the employee table. The purpose of this kind of things, we can take the backup. Suppose I'm going to do some operation over here. Maybe something happens to the data of the employee. I want to take a backup. So this kind of things can be done to take a backup, or maybe similar kind of table I need to create. Why I should create again this kind of DDL statements? It will take lots of time. Okay, it obviously a DDL statement, but the conventional DDL statement means column name, column data type, this kind of thing. We no need to type over here. How we can create it? Let me show you. So first of all, on top of which data set you want to create the table, you just mention the DQL statement here. It's basically a combination of DQL statement and DDL statement. Select star from employee. Okay, this is the data set. On top of this, I'm going to create a table. So the syntax is create table table name. Suppose the table name should be different from here because same table cannot be existing in a same database schema. I can create similar kind of table in other schemas as well. There will be no issue. But in the same schema, same naming convention of table cannot be residing. Okay. So create table employee. Let me put backup. Employee underscore backup. Okay. This should be my table name. I'm taking a backup from this table. We need to put a keyword called as. Create table name as put the database name here. Database name, sorry, the data set. Whichever data set you want to represent, just put the data set here. Okay, you can impose filter over here. You can impose any kind of operation over here. So whatever data set it will be representing over here, the same data set will be created in the new table. Let me run this table, run this query. I just ran it. Let me refresh the left hand panel. Yes, you can see a new table has been created. Let me query through the new table. Okay, you can see it's having the same data, whatever employee table was consisting. Okay, so this way we can create table from another data set. No need to put the conventional way of putting DDL statements. Creation statement, create table, table name, column names and all. If we already have a structure, okay, here we can maintain 2, 3 more things. Let me show you. Suppose I want to only copy the structure. I don't want to copy the entire data. Okay, so just like we can do two things over here. We can put any kind of filter operation, just like where, let me put this kind of thing, department equal, let me put such a department which is not available over here, so that when I'll be running this query, there will be no data, only the blank table should be selected. Let me show you quickly. Suppose let me put department equal some abbreviation, suppose PT. There is no such department available over here. So if I run this query, it will be throwing 0 records. Now if I run the entire query, suppose backup 1, this is my new table. If I run the entire query, the table will be created without any data. Okay, this table has been created, but there should not be any data. Let me show you quickly. Backup 1. So only the structure has been copied over here, but no data has been copied. Okay, this can be another application. Maybe in your requirement, there are large tables. Suppose 100 columns tables are there. You need to quickly create this kind of table for your local system, just for quick analysis and all. So there you can create in this way. Okay. Let me show you one more important thing. It's called Boolean filter. I haven't showed this thing during filter operation. So Boolean kind of filter is there. So this kind of thing, I put such a department which is not available. Okay. So we can uh, just transfer the same thing in Boolean. This kind of thing, 1 equals 0. Where 1 equals 0 means it's a false condition. There will be no data selected. This thing I haven't told you last day. 1 equal 1 means it's a Boolean true. It will be returning all the rows. Okay. Similarly, you can do this kind of thing as well. You want to copy only the structure of the table to your new table. You can just run the entire query. It will only copy the structure because 1 equals 0, it's a Boolean false. So it will not be selecting any records. When we will be trying to create a table on top of this, only the structure will be copied. No data will be copied. If you want to put the entire data to be copied, you cannot put anything, there will be no issue. Or you can put a Boolean filters 1 equal 1. Anything you can do. Okay. This is a good and standardized way to copy the table. Any doubt with the topic? Anyone? No one? Okay. I hope it's clear for everyone. Next topic, set operation. Okay. Set means we learned set theory in our maybe previous, graduation classes or maybe higher secondary classes. So what is set theory? We learned there union all, having Venn diagram. I hope all we know this kind of things. So same kind of things we can operate on top of data as well. Okay. So before going ahead with the example, let me create two separate table. Okay, I'm going to create two separate table. On top of the same employee table, I'm going to create employee IT table, which will be consisting only the IT department's record. The similar way I just showed you in the example. Select star from employee table where department equal IT. Okay. Just created the table. Similarly, I'm going to create another table, employee BPO. This particular table will consist only the data of the BPO employees. Okay. Okay, it's created. Let me refresh. You can see the last two table is present over here, having the same structure, but as per the things, I think you can understand the data should be different for each of the table. Let me quickly select on top of these two table so that you can quickly understand the thing. We'll start from so in the BPO table, there are only two records. That is fine. Let me just select on top of IT table. Yeah, it's only having the IT department's records. There are three different records available in the IT table. Okay, let's start the set analysis part. First thing is union. Union will be merging the entire records one upon another. Okay, let's do the union. So how to do the union operation? Just in between the two data set selection, I need to place the union keyword in between that. Okay, this is now a single statement. This is a single statement. Let me represent the thing in this way without any lines. I think that should be understandable. Okay, it's a single statement. Let me run this thing. You can see the output. Okay, so in union operation, what we are doing, we are merging two data set vertically, one after another. So first, we have two records from the BPO table. Then it's unioning with employee ID records. There are three records. So as of now, the entire query is giving the output of 5 records. Okay. There is another concept of union all. So union and union all, there should not be any difference with that operation. I'll be showing you another example, then you can understand the thing. There'll be no issue. For whatever output I receive for union, I receive the similar kind of output for union all as well. There is no changes in the data set. Okay, let's go ahead with the intersection. Intersect. Intersection means it will be giving the output with the common records. But in this two table, there are no common records. The first BPO table, it's representing the BPO one, and the IT table is having only the IT related department. There is no such common record. So the output of this query should be showing no records. Intersect. Intersection. It's showing an error. I think intersect is the keyword. Yes. So the keyword between these two data set, we need to use intersect. Okay. So there is no common records between these two data sets. That is why it's throwing zero value. Okay. Let's do one thing. Let's change this IT to employee table. Okay. Let's do the union operation first. So union is the mother table. Employee is the mother table, and employee BPO is a subset of this table only having the BPO related data. I'm doing this operation just to show you the difference between union and union all. There are two different things, and the questions may be arise in the interview. What is the difference between union and union all operation? So let's run the query. I'm performing an union. So you can see first we are fetching BPO related records. Okay. Then we are doing the union between employee records as well. But you can see all the employees records did not arrive over here. The BPO records from the employee table did not arrive in this data set. Because when doing the union operation, union will do two things. It will be merging two data set, that is fine. It will also remove the duplicates. Okay, so union is very, very powerful. It will not merge the data set only. It will also check the duplicates. If there is any duplication during union or union operation, then it will remove the duplicates. Let me show you union all operation. Then you can easily understand the issue. Union all means it will not remove any duplicates. Whatever data set is there, they will be just vertically merged one upon another. So this is the output of the data set. The first two records are from the employee BPO table. Okay. And the last records you can see BPOs are available there. So there are duplication just like this one and this one. These records are totally duplicate. Similarly, this record, the another BPO employee, and this record 116 employee ID. It's also duplicated. So union all, it will not remove any duplicate. Rather, whatever data is present in both of the data set, it will totally merge them one after another. Okay, so this is the difference between union and union all. Let me just quickly show you the intersect. There is no issue. As this is a subset, employee BPO is a subset of the main employee table. We can find some of the record is present during intersection operation. We select and yes, because this is a subset only BPO related employee. It's present or available in both of the data set. That is why this is the output of the intersection. Okay. I hope there is no issue. Okay. Now, one more important concept to perform this kind of set theory, we just need to be cautious that when we'll be performing this set theory, the same number of columns should be there for each of the data set. Same number of columns, same number of column functionality. Otherwise, the union should not be having any fruitful results. Okay. Did you understand? Suppose one of the columns, suppose this column I am having employee ID in employee BPO table. And the second table it's having a different things over here. Suppose experience is there at the first column. Although the column numbers are same, there are total 1, 2, 3, 4, 5, 6, 7 columns for employee employee BPO, and the 7 number of columns are also there in employee table, but the orders are not matching. Then the resultant data set, it will not give us the proper output. Okay, the output should not be the meaningful. But if we use separate number of columns, suppose two data set is having totally different number of columns. Someone is having 2 or 3 columns, some table is having more than that. If we perform this kind of things over here, it will throw error. It will be throwing error, just like mentioning union operation will not handle different number of columns. So the first thing we need to just assure while doing any union or intersection, any kind of operation, there should be same number of columns along with the columns orders are same and their representation should be same. Maybe there are employee ID in employee tables. The same column is being represented as employee number, EMP, as the functionalities are same. There is no difference between employee ID and employee number. There will not be any issue while merging the data set that time. Okay, maybe the column name can be different in this operation. There will be no error. But if there is any difference with the column name, it will immediately throw an error. Let me quickly show you. I'm taking all the columns from employee BPO table. I'm just doing an employee ID, selecting employee ID, employee first name from the second table. I'm doing the intersect operation. Throw the error. So the select statements have a different number of columns. Okay. So it will be throwing an error if the column numbers are different. Okay. So any doubts so far from anyone till now? It's clear for
All
everyone?
good, sir. All good, sir.
Okay. Okay. Thanks, Anirudh. I hope it's clear for everyone. But if there is any stuck point or anything, I can find new faces as well. Naveen, is this your first class? Ramesh Sri, or I cannot recall the name.
Yes, this is my first.
Okay,
Yes.
Ramesh Sri, these things are understandable.
Yes, yes.
Oh, you already have the experience in data earlier.
Yes, yes. I do have a knowledge on that, but still
Oh,
I'm just
okay, okay. Then it should
revising.
be good. Yeah, yeah. Thanks, thanks. Okay. Ravindra, you want to say something? I just find you
Yes,
unmuting
sir.
yourself. Yeah,
Sir,
tell
I
me.
just, this is my first lecture. I wanted to ask you, how did you load the employee data in the SQL database?
Okay, this thing has been covered in the last 2 day session.
Okay,
So
okay,
first we have learned the create statements. I mean, it's a DDL.
okay.
Then we
Yes,
learn the
yes,
DML, data
yes,
So,
manipulation languages.
sir, it's a
yes,
random data, right? You created it.
No, yeah, random data. I created the data
You
only.
you created. Okay,
I created.
got it.
So Ravindra, I have created those data in the last sessions, and got to know how to load the data by DML executions and all. So this thing we have
okay,
done and covered in the last session. You can just quickly go through
okay.
the recordings. Do you already have the experience in data earlier, or this is
Yes,
quite new for you?
I am a software engineer. I have a basic understanding.
Okay, then there will be no issue.
Yes,
So it should be fine for you, as the
Sir,
course
I
is
have one
totally for the
question.
basics. Yeah, tell me.
So we have not yet come to the joins, right?
Yeah, joins is the next topic I'll be going to teach you.
Okay. I have
Okay.
little tough job in that.
Yeah, sure. Join is the most important thing over here, as this is a relational database. I'll be quickly going to start it.
Sure, sir.
So before starting join, I hope we all are good. But if there is any stuck point from anyone, please stop me and ask me question. Okay, I'm going to start join now. Join is our next topic. So you have join means join between multiple data set. So during our first or second classes, I showed you what is a foreign key concept, what is primary key concept. We are uh, just like when we are doing the normalization part in the second day's class, we are splitting the table, but we are keeping same number, same kind of columns into different data set, because when required, we can pull the data doing a join. Okay, pull data from one table to another table doing a join. So how join can be performed? Okay, let me show you quickly with the day two, if it's possible. I have one question. Kila, what is this? This is for day 2 session.
So all the recordings are here, the sessions
Okay.
which are covered so far.
Okay, thanks. Yeah, that should be helpful for other.
Yes.
So I'm just going to show you the data set, what we have learned in our day 2 or day 1, anything. Suppose in day 2, what we have learned? Let me quickly check it. For join, let me show you something, some data related concept first. After that, I'll be coming to the syntax part. Okay. Okay, we learned this kind of thing. We have converted the normalization stuffs. I think this is understandable for everyone that time. So I'm just going to the ultimate. When we are converting the table to second normalized form, this is our final result. We have splitted the data set into 2 different data set, and this is our final result. Okay. So in this particular 2 data set, you can see both of the data set is having the common column course ID, course ID. I'm not coming now the primary key, foreign key concepts. Now, just to quickly mention that this is the primary key of this table, but I'm not coming the primary key concept now. As of now, let's focus only the common columns by which we will be doing the joining part. So this 2 table is having the common column course ID. Suppose I just need to know what is the course fee for Pankaj. Okay, I cannot see the course fee over here, but the course fee is there in the separate table. We can join between these 2 tables. Over here, I can quickly see and I can tell what is Pankaj, how much Pankaj need to pay in the coaching institution. Pankaj needs to pay A11, that is 500. This is very small data set. That's why I can quickly assume it. I can quickly see it. For Sonu, say A12 and A13 is tagged with him, her. So I can quickly check it from here A1 to A13. Sonu needs to pay 800 plus 300. Raj is also learning 2 separate courses A11, A14. I can quickly check it and add it. I can quickly, actually I'm doing join in my mind over here between these 2 data sets, and then I'm doing the calculation. But when we have larger data set, maybe 1,000, maybe lakhs of records, we cannot do this mind calculation doing the join. Rather, we need to perform the join in our SQLs. Okay, we need to just fetch data from another table based on the common columns value. This is the concept of join. This is why join is required. Okay. Let me show you with another data set with the examples. What are the different kind of joins are. I'm closing this thing. So today's day 3 SQL. I also have some data sets. I'm not directly going to the syntax. Let's learn the things from the Excel data. When the concept is clear, we'll be moving to the SQL syntaxes, how to do the join. Okay, first of all, join is of 2 types, inner join and outer join. Okay, let's come to inner join first. What is inner join? So suppose we have 2 different data set, employee ID, employee age. This is one data set, and this is another data set, designation and employee ID. As of now, don't think about primary key and foreign key concept. You can merge the concept later after performing the join and all, no issue. But as of now, while learning the things, just put aside the thing what is primary key, what is foreign key as of now. Okay. So from this data set, we have employee ID. From this data set, we also have the employee ID. So employee ID is a common column for each of the data set. So we can join, if we just going to perform the join, can use the common column employee ID. Okay. So while performing the inner join, now while performing any kind of join, we should be having our resultant data set. in our resultant data set, we have the capability which columns I need to pick from which table. Okay. Suppose I'm picking employee ID from the first table. At the resultant data set, I'm telling about. Okay. Employee age, I'm picking from the first table because employee age doesn't have data from second table. Employee age, I need to put from first table, and designation only I'm putting it from here. Okay. If we perform inner join should be based on common columns, that is employee ID. So common columns data should be matched with this one. So 1 is matching over here, 2 is matching with these two, 3 is not matching. No 3 is there, even 4 is not matching, 4 is not here. So we have two common, matching records, 1 and 2. 1 and 2 here. Okay. So 1 and 2 is here. That is why all the respective attributes for 1 and 2, just like employee age is also present here. And for 1 and 2, designation is also been kept over here. This is how we are doing join. So you can see earlier we do not have the combination of employee age, employee's designation in a single data set. But after performing join with a common column, I can represent the join. So this is the purpose of join. We have multiple data set. Each of the data set is having different columns combination. Why we require this? That is required in normalization chapter. We covered why we, maybe the requirement is this, why we are not putting everything in a single table, because that should be denormalized, and that is not the good way of representing the data in database. Okay, that is why we are keeping separate table, but we are keeping some of the foreign key, primary key relationships such a way so that we can perform the join when it's required. Okay, so, and this is the purpose of join. By the join, we can pull all the columns which are required in our resultant data set. It's clear for inner join for everyone. The concept is clear for everyone. Okay, let me go ahead with the left outer join. In the outer join, there is two main things. One is called left outer join. One is called right outer join. While performing left outer join, it's also called left join. Left join and left outer joins are same. When we are performing left outer join, then we need to mention one table as the left table and one table as the right table. Let's assume this is our left table, this is our right table. So during doing the left join, the left table should be considered as the standardized table. So in the common column, that is employee ID, whatever data is there, I need to pick those records compulsory. Okay, I do not have to check first with the matching stuffs. So as I mentioned in the left table, the left table standardization, left table should be the standardized one. So I'm pulling all those 1, 2, 3 from here to here. Along with the other data from the left table, that is employee age, is also pulling from here to here. Now the designation is coming from the right table. While pushing the designation over here, I just need to match these employee IDs to here. One is matching, that is why data scientist is kept over here. 2 is matching, that is why senior manager is kept over here. They're searching for other records if there is any matching for 3. No matching for 3, that is why null has been first into designation column. Okay, unlike inner join, only both of the data set having the common records, only those things can be pushed in the final data set. But over here, the left table's data should be kept first, and we will be checking if there is any match. On the right table, we will be pulling them. Otherwise, it will be passed as null value. Right join. While performing the right join, I am changing something. Suppose this is our right table, so this is our standardized table. While taking data from right table, I am taking employee ID from here. I'm not taking employee ID from here. Okay, I can also take employee ID from both of the column for each of the cases. Suppose let me put employee ID from left table. I'm mentioning this way. Left table. This is my right table. Okay. I mean this employee ID is keeping data from right table. So employee ID from right table, it's taking all the things because this is the concept. Similarly for left outer, when I'm taking all the things from left outer, it's just like the different things for right table. Right table, I'm taking all the things. Now I'll be checking 1 to 4 is present over here. Not, it's not. So whatever data is present in the left table, I just need to pick this thing. 45 and 48. For employee ID 4, there is no data in the right table. Sorry, left table. That is why no data has been picked up. But for designation, I can pull all the things. Similarly, employee ID, I can put the same kind of things. 1. This is 1. Sorry. Why it's not getting printed? I'm not going to print anything. What happened, man? No, something would happen. So over here, I need to put 1 and this thing, it will be 2 over here. And there should be null value. I'll be closing the Excel and let me open the Excel once more time. Just give me some second. Sorry for that. The cell is deactivated. Okay, now it's working. Okay. So I'm just passing this thing employee ID left just to show you this employee ID is coming from the right table. Okay. And I'm just keeping another column called employee ID left just to mention which employee ID is coming from which table. This should be null because this is our standardized table now. I need to keep all the things from this table and which references are matching in this. I just need to pull these things over here. So this is the concept and this is how right joins work. Any doubt with the left join and right join? While understanding, I'll be repeating once more time. Any issue while learning? Left join and right join, it's clear? Okay. So there is full join as well. Full outer join. Full join means I need to take all the data, whether they're matching or they're not matching. The record should be a bit different over here. Let me just modify a bit. It's not correct. So let me put employee ID left from here. Designation. And yes. And let me put employee ID right. Okay. So it's matching, only 4 will not be present over here. From the thing, it should be null. And over right table, 1 should be there, 2 should be there, 3 will not be there. It will be passing null because there is no 3 and 4 should be present over here. Designation is analyst, correct. So this should be the output of full join, full outer join. It is coming under outer join section, left outer join, right outer join, full outer join. So what of the leftover things in left outer join, that should be present over here as well. We'll be keeping both of the tables record together. Okay. For 3, there is no matching. Employee ID 3, there is no matching for the right outer table. That is why it's passing null value from the column switcher coming from the right table. Similarly, for employee ID 4, there is no data from the left table. That is why it's taking the data from right table, but it's passing null value from the left table. This is the concept of full join. Okay. Apart from that, there is cross join. Although this is very minimal, I mean, very less operations or applications you can see with the cross join. Cross join is simply crossing the data. For each combination of the first table's record, the data should be crossed. Just like 145. This is the first record of the left table. For each of the table, the things will be repeated. 145 will be repeated 3 times because there are 3 different records. Data scientist, senior manager, analyst. For 248, again, the thing should be repeated. It's simply mathematical cross. We are crossing the thing. So while doing the cross operation, the data should be multiplied. There are 3 records. So at the resultant output, there should be 3 cross 3, 9 record. But the application is very minimal. In our practical or maybe when we'll be live in a project, we can see the things are, not very applicable. The cross join is not very applicable. Okay. Okay, the syntax part I'll be covering tomorrow. I'll be creating the same kind of table in our data set. SQL workbench, and try to perform the join with the syntaxes. Before that, I'll be showing some more exercise in Excel. I prepared this thing. Maybe okay, let's cover this thing in tomorrow's session. So as of now, any doubt, any stuck point, whatever we have learned during join in this Excel from anyone, it's clear?
Sir, I have a question.
Yeah, Ravindra.
Sir, even if the employee ID is unique and primary, there will be 2 copy in the full joint, like the left employee ID of the left table and the employee ID of the right table.
So if there is, you can see. Okay,
Yes.
what is your? I actually didn't get. So if there is totally matching things, you are talking
If the
about.
table name is same employee ID and it is unique primary key, still it's going to give the same output, like 2
Yeah,
different employee IDs of left and right.
correct. If the employee
won't
IDs are unique
merge.
but
Yes.
different. Okay,
Yes.
can you please tell me a data set quickly? I'll be showing you. Suppose employee ID I'm taking. I'm just changing the data set.
Okay.
Employee age. So what thing you want to represent quickly? You can suggest me.
1, 2.
1, 2.
No, in the existing example, can you show in this 2 table that we have employee ID, this and right employee ID, in which case there will be only one employee ID, in which join? Suppose in the left join there was one employee ID. In the right join there was just one employee ID column. In the full join there were 2 employee ID columns, one for the left and one for the right.
No,
Am I
no, this
getting
is
you
not
right?
the concept. This is not the concept.
Oh.
Okay, let me show you. I can
Okay.
also, in the resultant data set, it's totally our wish, which things I need to take. Suppose in inner join, I can also take the
Okay.
data. I'm just picking up. Okay, let me show you. I can also take this kind of data in inner join as well.
Okay, understood. We have to select the column that we want.
Correct. At the final data set, it's our own wish which particular column I want to give as,
Display.
as our output. Okay, you can see
Okay.
right join as well. I can take two different. This is for right.
Yes.
Okay.
Yes.
Let me show you. I can take employee ID left. I cannot take same name convention. That is why I need to change it, because in the data set when I'll be writing the query, I cannot, in the resultant data set, there should not be same kind of column. That is why I'm just aliasing it, employee ID to employee ID left. This is as right. So I have to mention in this way. Okay, so this is the output of inner join. Similarly, I can do the left from here, right from here. I can mention the thing. Okay, now the concept is clear. Or
Yes, yes, sir. So I had this question. How will you display all the 4 employee ID? Like which join would you use to display all the 4 employee ID in one table? Like
it's a
1, 2,
right.
3,
It's a
4.
full outer join.
Full outer join, right?
Yeah,
Okay, sir.
but
Got
all
it.
the things should not be coming in the same column, because from the left table's
Okay.
contribution there should be 3. From the right there should be
Yeah.
4. I mean 1 to
Okay.
4. So in full outer join I am getting all the things now, but not 1, 2, 3, 4 in a single set. Okay.
Okay, sir. Got it. Thank you.
Okay. So maybe it should be totally completed when we'll be going ahead with the syntax part. Okay. When we'll be learning the syntax, as well as I'll be giving some advanced levels of joining over here. I prepared some exercise. So please go through or just clear your mind. Inner join, left join, right join. I'll be asking question tomorrow with the exercises. Then we'll be going to the SQL syntaxes. If we have, we are clearing our doubts over here, then there will be no issue with the joining syntax. Syntax is similar. It's very simple. Just need to put the syntax. That's it. But the concept should be clear, because in the interview they will be just directly giving you the data set. Okay, and they will be telling what should be the resultant data set. If you are joining in this data set and this data set, what should be your resulting data set? So they will be asking the question just like this. But just clear your concept, because the same join we will be using during the Python or any other thing. Maybe in the big data we are doing data frames joining part. So the same kind of concept should be there as well. Concept is same for join, but the syntax is different. Okay, so first clear our concept about the join, then we'll be going ahead with the syntax part. Okay, so that's all for today's session. Let's connect with the more insights on top of join. Let's cover up the join and learn the syntax. Okay, that's all for today. Let's connect tomorrow. Thank you, everyone. Bye-bye. At the same day.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.